Okay, so we got 3.8 linear quadratic systems. When you were in grade 9 or grade 10, you learned linear systems. That's when two lines intersected. So now we're talking about when a parabola and a line intersect. And where does that happen? So the points of intersection. The first example we're going to graph, and then we're going to do it algebraically. So f at x is the basic parabola. So you should remember those points. 0, 0, 1, 1, 2, 4, 3, 9, and reflected on the other side. Oops. And then we're going to draw g at x, which is a line. It's linear x plus 6. So we have a y-intercept of 6, and the slope is the coefficient in front of x, so 1 or 1 over 1. So you plot the point at 6, which is a y-intercept, and then using your slope you find more points. So up 1, right 1, up 1, right 1, etc. And we can see that it intersects when y is 9. And then if we go the other way, we go down 1 across 1, and we can see it intersects again. It's g at x, this is f at x, and we have our points of intersection highlighted there. So 3, 9, and negative 2, 4. Therefore, the points of intersection are negative 2, 4, and 3, 9. So what it means to find the points of intersection is when those two equations are equal to each other. Excuse me. So f at x is equal to g at x at those points. Which is what this says. So another way that we could do it is algebraically. We could say that f at x is equal to g at x. So x squared is equal to x minus 6. And if I'm solving for x, I would rearrange by doing the opposite operations to make it equal to 0, right? So on the left side, I have x squared minus 6 plus 6. And then we'll factor x times x, 3 times 2, doesn't work. Oh, sorry, it's plus 6, my fault. It's plus 6, so here is negative 6. So that works, because we want negative 1 in the middle. So factored is x minus 3 and x plus 2, which means one x value is 3. The other x value, or the other root, is negative 2, which is what we found above. It's just we don't know what the y value is. So you need to figure out what the y coordinate is by plugging it into any one of f at x or g at x. So if I find f at 3, which is 3 squared, it's 9. F at negative 2 is negative 2 squared, which is 4. So that's how we got the points. 3, 9, and negative 2, 4. Okay, so you can do it algebraically, you can do it graphically. Now, graphically, it's only good if it actually works out to a nice point, but sometimes they won't. So algebraically is usually the way that we'll be doing it. So if I don't tell you to graph it, then don't graph it. Okay, don't try to make up your own graphs. All right, so the word problem here, Justin is skeet shooting. So that's when there's like, it's a guy standing here. He's got a gun. But he's not shooting anything living. It's just a disc that gets shot in the air. Goes up and comes down. And he's trying to shoot it. So we want to know when does he shoot the disc. So the height of the skeet, the disc, is h at t, where h is meters, blah, 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 blah. The path of Justin's bullet is multiplied by g at t with the same units. How long will it take for the bullet to hit the skeet? So we want to know when this happens. And we're talking about the line and the parabola. It's the point of intersection. So it's hard to come up with application questions. So that's why they sound like this. Skeets and bullets and whatnot. So we want to know when h at t is equal to g at t. So we'll make the equations equal to each other, but since it's a quadratic, I'm going to make it equal to 0. Negative 5t squared plus 0.5t plus 1 is 0. So I'm looking for t, for time. So let's solve for t. I could either factor or use quadratic formula. Now, since there's a decimal in there, I'd probably just go straight to quadratic formula. So t is equal to b plus and minus the square root of b squared minus 4ac over 2a. So 0.5, negative 0.5, plus or minus 0.5 squared. Make a little more space. It'd help if I had a calculator. Let's see. This is why I always ask you guys to do things, because I don't have a calculator. So 20.25. negative 0.5 plus or minus, oops, square root of that is 3.25, 4.5, negative 10. So if we add, I'll get 4 over negative 10, which is a negative number, so I know that can't be the answer. But if I subtract negative 0.5 minus 4.5, I'll get negative 5 over negative 10, which is 0.5. So when t, or time, is 0.5, half a second, that's when the bullet hit the disc. And how high off the ground will it be when the bullet is hit? So you're finding either h at 0.5 or g at 0.5. Doesn't matter which one. So I would think that g would be easier to solve. So g at 0.5 is 31.5 times 0.5 plus 1. So 16.75. So therefore, the skeet is 16.75 meters high at 0.5 seconds. Okay, so if you needed to copy, just pause the video. A function, quadratic function, is defined by f at x, a linear function at g at x. What values of the slope of the line would make it tangent to the parabola? So, a couple of things here. You can see in g at x, I don't know what the slope is. We have to figure out what the slope is. That's the point of the question. And it also says tangent to the parabola. So tangent means it touches at a single point. If it touches at a single point, that means there is one point of intersection. So if there's one point of intersection, that means when I say that f at x is equal to g at x, that means there should only be one answer. So let's try this. I'll change to blue here. 3x squared plus 4x minus 2 to mx minus 5. Okay, well, I can't solve this. I have two variables, which is bad, but also it's not equal to 0. So let's move everything over. So I'm going to rearrange the equation. I'm going to bring mx over by subtracting mx. And I'm going to add 5. So that's equal to 0. Now, if I simplify this, I'm going to leave the x's for a second. But this will be plus 3. Now, 4x minus mx. I can't subtract this. They're like terms because they're both x, but the problem is I have a 4 and an m, right? Now, if this was, say, another number, I don't know, 5 or 2. To subtract these, I would just do 4 minus 2, so I'd get 2x. But because it's m, I can't do that. So instead, what I can do is subtract 4 and m. So I'm going to say 4 minus m x. Excuse me. So if I knew what m was, I could subtract it, but I don't. So I'm just going to say 4 minus m. Now I know that there's one point of intersection. So if there's one point of intersection, means there's one solution. And if I'm solving for x here, that means that there's one root. If you think back, when did that happen? It was one root when the discriminant is equal to 0, or b squared minus 4ac is equal to 0. So in this case, because we have two variables, b is all of this, 4 minus m. Then you have a and c over here. So we plug that in to our discriminant. So now I'm going to solve for the slope, m, to give my equation, or my new equation where I combine the two, the quadratic and the linear, find out what the slope is so that I have only one solution. And that's because the discriminant is equal to 0. So I'm going to expand this and simplify. So remember a binomial squared, you square the first term minus 2 times the two terms, so 8m plus m squared. Now, you could always just do 4 minus m times 4 minus m to get the same answer. And this will be 36. So if I rearrange this, I get m squared minus 8m minus 20. So I have a quadratic that's equal to 0, and the way we solve that is by factoring. So let's get it to factored form. Negative 10 and 2 will work here. So m minus 10, m plus 2. So now we're talking about m's. All the x's and stuff are gone, right? Because we're not talking about what the x value is. I don't care about the zeros. I want to know what the slope is. That's what the original question asked me. So when I combined the slope in with the quadratic, I put it into the discriminant to figure out when we'd have one solution, when it's equal to 0. So when is m equal to 0, or the equation with m equal to 0, when m is equal to 10, or when m is equal to negative 2. So we figured out the slopes. There's actually two slopes. That's why it said values. So when m equals 10 and m equals negative 2, the line is tangent to the parabola. Let me show you what this would look like in a quick sketch. I'm not going to be able to graph it exactly, but we'll do a quick sketch of what this could mean. You know what? Why don't I do it in Desmos, and you'll be able to see it a little easier. So 3, 4, negative 2. And so that's our parabola. And then we had the line. So one of them we said was 10, a slope of 10, plus, I don't remember now, minus 5. Sorry for all the switching. So if you look at the graph here, I know it doesn't look like it because it's kind of looks like it's on top for a long time, but if I zoomed in a lot, then you'd be able to tell that it only touches at one point. And we could find out what that point is, but we're going to skip that there. So just trust me. It's just because of the scale. You can't really tell that it only touches at one point, but we have a line here. It has a y-intercept of -5 and a slope of 10, and it touches the parabola at one single point. So it's one point of intersection. But we had another possibility. So what would that look like? -2 x minus 5. So it has the same y-intercept, but a different slope to touch at that one point. This one's a little bit easier to see that it touches at one point. If I zoomed in a lot, you'd see it. But I'd have to zoom in really close. Okay, so I'll attach this to the handout, and then you guys can either graph it yourself or just print it out so you can see what it looks like. Okay, so good luck with the homework.